Hello, my A1 pre-calculus class. We are ready for another online adventure. Today, we are going to sketch one cycle of the secant function. And the secant function has two pieces also. It's just that the two pieces will be shifted from the cosecant that we did yesterday. Here is our general form for our secant curve. And y equals secant of x, and I have the a being 1, the b 1, no c or d present, so they're both what, 0. We're going to be using our 5 steps again to graph one cycle. So I'm sure you're used to these 5 steps now. And we have to remember that secant of x is equal to 1 divided by the cosine of x. And wherever the cosine of x is equal to 0, that is where we're going to have our vertical asymptotes. So when we get ready to sketch our secant function, let me move this over so you can see it. We're going to first of all graph its reciprocal function. And we're going to remember that the period is 2 pi divided by b, and the inequality is 0 is less than or equal to bx minus c less than or equal to 2 pi. So when we're starting here, we're going to graph one cycle of a secant curve. The first thing we're going to do, we're going to graph y equals cosine of x. And using our 5-step procedure, the first thing we're going to do is put the bx minus c in between these two endpoints here, but there's only an x there, so we can't solve it anymore because our goal is to get one x in the middle here when we have our inequality. So here's the first critical number, the fifth critical number. We have our period being 2 pi divided by the absolute value of b, which will give us 2 pi. Our increment is the period 2 pi divided by 4, which reduces to pi over 2. Then we're going to find our 5 critical numbers. So 0 was the first one. Remember, we got that from the inequality. Then we add our increment, pi over 2, add our increment, pi, add the increment, 3 pi over 2, add the increment, 2 pi. And our 5 critical numbers then will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's look at the graph of this cosine function. Since the a is greater than 0, it's going to look like this, which means that once we put down our 5 critical numbers, at the first critical number, we're going to have a max point. At the 5th critical number, we're going to have a max point. At the 3rd critical number, which is in the middle, we're going to have a minimum point. And the 2nd and the 4th critical numbers are on the axis. So that's one sketch of our cosine function. Now, to graph the secant of x, remember, we have to remember that that's the same thing as 1 divided by cosine of x. So wherever the cosine of x is equal to 0, wherever it's intersecting that horizontal axis, we're going to have a vertical asymptote. So right here, you see it's intersecting the axis here at pi over 2, 0, so we have vertical asymptote, vertical asymptote. Then we're going to sketch our branches. And right here, see, this part is concave down. Remember, it's like down in the valley. Like the cosine function is down in the valley. So we're going to have a portion that's concave down. If you look at the dashed cosine function, this is like a mountaintop. Remember, up on the mountain, and we just have 1/2 of it here at 0 and 1/2 at 2 pi. Well, a half plus a half gives us, what, 1 whole. So we'll still end up with what, the 2 pieces of what our secant function when we graph it. Now, if you didn't like that 1/2 and 1/2, what you could do, you could extend the cosine function back this way. See the little green dashed? And this time, since I'm going in the opposite direction, I will subtract the increment and make pi over 2. So I'll have another vertical asymptote, but negative pi over 2. And then you see I could have what? Just 1 whole here. See, this is the mountaintop right here on the cosine function. So up on the mountaintop, it's concave up. And you'll notice that you look at each branch separately. Here, This will be a minimum point at 0, 1. Okay, this will be a maximum, see it's concave down. This will be a maximum point at pi comma negative 1. Again, you have to look at what each little branch separately. So what I was just showing you there is the same thing that I'm showing you here about what the max for y equals secant of x, about the max, the min, and the vertical asymptotes. Next, we're going to do this graph. We're going to have y equals 3 times secant of x divided by 2. So the first thing we're going to do, we're going to graph, and you see I left off the graph. We're going to graph y equals 3 times cosine of x divided by 2. Now, x divided by 2 is the same thing as 1/2 times x. So the a is 3 and the b is 1/2. We solve our inequality. Let me move this over so you can see it. So here's our bx minus cb. We want 1x, not 1/2 x there. So the way we'll undo dividing by 2 is we multiply by 2. When we do that, we have 0 is less than or equal to x, which is less than or equal to 4 pi. First critical number, fifth critical number. Then we're going to apply our period formula. 2 pi divided by the b. Dividing by 1/2 is the same thing as multiplying by its reciprocal. So we have, 4 pi for the period. And then we're going to find our increment, which is going to be the period divided by 4, which is pi. We start off with our first critical number that we got from our inequality. Then we add our increment. And you see pi, 2 pi, 3 pi, 4 pi. And these are our 5 critical numbers. So the first thing we're going to do, again, I'm going to sketch y equals cosine of x divided by 2. The a is equal to 3, which is greater than 0. So that means that we're going to have, at the first critical number and the fifth critical number, we're going to have max points. At the middle, or the third critical number, we're going to have a minimum point. At the second and the fourth critical numbers, we have axis points. And we're doing this to find where we're going to have our vertical asymptotes. So you see we have a vertical asymptote at pi, because see it's intersected, the cosine function is intersecting the axis here, and at 3 pi. And see this is like a valley for the cosine function, down in the valley, concave down. Remember these branches are approaching these vertical asymptotes, never crossing, never touching. And this is a half, and this is a half, and a half plus a half will give us a whole. And again, if you wanted to extend this to get the whole concave up, you could also, see, subtract the period or add the period, and you could get the other parts there. So here is a concave up. So this is going to be a minimum at 0, 3. Here is a concave down. So it's going to be a maximum at 2 pi comma negative 3. And here is another concave up. So we're going to have a minimum right here at 4 pi 3. So what I did there, I have minimum values. You see what I was just showing you on the graph, the maximum value, and then I was showing you whether we had the vertical asymptotes. So when you're doing this, always remember, what did I say? You gotta stop, rewind, and review. My love going out to